Hello and welcome to Chemistry Lesson 3.04, Mole Conversions, Part 1. In this lesson, we're going to go over how to use the concept of mole and molar mass to convert from atoms to grams. So to kind of give you a heads up, usually what we'll do is I'll go over the tips and the hints first, and then we'll go over how to do the mole conversions. But some of you don't need the tips because you just get it right off the bat. So I'm going to reverse the order this time, and we're going to go over how to do the mole conversions in part 1. And then in part 2, we're going to go over some tips, tricks, hints that you can use if these are a little bit difficult for you. So we started off and we had a dish of copper, and I said, can you tell me how many atoms are in this dish of copper? If I handed you a dish of copper, and a couple of videos ago or a video ago, you would have said, no, I can't tell how many atoms there are. But that's what we're going to do. We're going to start off with. So the first thing you have to do is you have to have a mass. So let's say the mass, uh, if I have a dish of copper that weighs, so let's say we put it on the scale and we find out it weighs 48.6 grams. How many atoms is that? The first thing you're going to need, if you think back to dimensional analysis a couple of chapters ago, the steps that we use then are the steps we're going to use now. So the first thing you want to do is you want to frame up your problem. So I'm starting off with 48.6 grams of copper, and I'm going to put that over 1. And my question word is how many atoms? So over here, I'm going to go to atoms. So step 1 is to frame up your problem. Step 2 is to assemble your conversion factors. And for these problems, your conversion factors will always be, you'll always have 2 conversion factors. One conversion factor will be molar mass. And the other conversion factor will be Avogadro's number. So the molar mass of copper we get off of the periodic table, and if we looked at the atomic mass on the periodic table, we would see that it's 63.5 atomic mass units. When I write it as molar mass, I'm going to put 63.5 grams of copper in 1 mole of copper. I can't emphasize enough how important it is to get this down, to understand that you have your atomic mass in 1 mole. I'm going to write these flipped just so you remember that conversion factors can be inserted both ways. And then Avogadro's number is always 6.02 times 10 to the 23rd of something. And in this case, our something is atoms in 1 mole. And in this, we're talking about copper, so let's write it that way. And I'm going to write this flipped. We'll just number these 1, 2, 3, 4. All right, so I've framed up my problem. I've assembled my conversion factors. So the next step is to insert your conversion factors. All right, I have grams on the top, so I need a unit that's going to give me grams on the bottom. So do I want number 1 or number 2? Hopefully you said number 2. All right, grams is going to cancel. Now I have moles on the top, so for my next factor, I'm going to want moles on the bottom. And do I want 3 or 4? Hopefully you said number 3. Notice I am keeping my labels. It's really important to keep your labels as you go. All right, my next step is to cancel my units to see if I set up my problem correctly. Remember, this one is only a placeholder. There is no unit here. And for all our problems, pretty much for the rest of the year, there should not be a unit on the bottom. So if I come around and I look at your problems when you're working in class and you've got a unit on the bottom, it's not going to go well, or it's not going to work. So let's see, grams cancels, grams of coppers cancels, moles of coppers moles cancels. When I multiply 48.6 by 6.02 times 10 to the 23rd and I divide it by 63.5, I get 4.61 times 10 to the 23rd atoms of copper. So here's the takeaway. If you take any element, if you take any substance and you get a mass, you can convert it to the number of atoms that are in that particular mass. And notice it's a pretty big number. Well, atoms are really, really small, so that kind of makes sense. All right, let's do another sample problem. Sample problem 1. So let's go with 2. How many moles of helium are in 86 grams of helium? Okay, well, let's frame up the problem. So I'm starting with 86 grams of helium. I'm just going to put that over 1 as a placeholder. And my question word says how many moles? So I'm solving for moles. Next thing I need to do is to assemble my conversion factors. Okay. When I look on the periodic table, I see that the molar mass is going to be 4 grams of helium in 1 mole of helium. I'm going to write these both ways. I also know that there are 6.02 times 10 to the 23rd atoms of helium in 1 mole of helium, and vice versa. Okay, so I've assembled my conversion factors. Now I want to insert them. Well, I need to go from grams to moles. Well, check this out. If I look at this factor, I have grams on the bottom, so I have moles on the top. Isn't that going to get me where I need to go? And the answer is yes. So I need to cancel my units. I set this up correctly. And when I multiply and divide, I end up with 21.5 moles. Well, hey, I didn't need these at all. The more you do these, the more you'll become accustomed to whether or not you need all 4 conversion factors. But again, this can be problematic. And so if this is an issue for you, I recommend watching the next video where we go over a little trick that I give you, a little diagram that you can use to figure out how many conversion factors you need and which conversion factors you need. All right, let's do one more. Let's say, how much, or you know what, I'm going to change this. What is the mass, this is more correct, of 1 atom of sodium? What is the mass of 1 atom of sodium? And I'm going to, let me cross that out. I'm not going to get out my, I was going to say, what does it weigh? And that's actually not scientifically accurate. So I changed my mind. Okay, well, if I'm solving for mass, what is the mass? There's my question word. That means I'm solving for grams. Well, what am I starting with? I'm starting with just 1 atom of sodium. going to put it over 1 as a placeholder. And this is kind of in my way now. I'm going to go to grams. All right, so I need my conversion factors. If I look on my periodic table, I see that there's 23 grams of sodium in 1 mole of sodium. The biggest mistake is that people make is writing these. They'll put 1 mole of 1 gram of sodium in 23 moles. So you have to know that it's grams per mole. And I've got, you know what? Let's do this. This time I'm going to not write these flipped. Let's see if we can do it without flipping them. Okay, I also know that I have 6.02 times 10 to the 23rd atoms of sodium in 1 mole of sodium. All right, now I need to, I've got my frame up, I've assembled my conversion factors, now I'm ready to insert. I'm starting off with atoms. That means I'm going to want to use this conversion factor, but I've got atoms on the top over here, so it's going to have to be flipped. So I'm going to put 1 mole sodium over 6.02 times 10 to the 23rd atoms of sodium. I've got moles on the top, so that means I can put this guy in as is. So this is going to be 23 grams of sodium over 1 mole of sodium. All right, I want to cancel my units. I'm left with grams of sodium, which matches what I have over here. And I forgot to punch this one in my calculator. So and this should be a really small number, right? It should be a big negative exponent. And sure enough, because think about how small an atom is. That's really, really small. I get 3.82 times 10 to the minus 23rd grams. Because 1 atom's really small. All right, if you understood this, if you feel like you get it and you can go just jump into this homework, go ahead and skip part 2. If you're not quite sure where to start, if you find that you've got some uncertainty, please continue on to part 2, and I'll show you a little diagram you can use to help you figure out what you need and when you need to use it. All right, that's part 1. Thanks for watching and have a good day.